Hello everyone. You know, these days a smart grid is very fast under development. So if you look at the different parts of the world, they are talking about the smart system, a smart city, a smart building, a smart grid, and whatever is actually smart. One of the main basically features in the smart grid is the smart meter for our building, for our commercial places, or even for industry. So at Nazarbayev University, in the recent years, so we have been trying actually to develop the smart meter, which is working with the cloud, and based on the Internet of Things, it can transfer the data actually to the cloud, and we can read the information and data from the cloud, bring it over the mobile phone application. This is something which we have been developed actually at Nazarbayev University. So, however, in the meantime, we have been trying to develop the in-home display or on-site display actually for our meter. So we have got a physical meter, as you can find it here, which I'm going to present today for you. And the smart meter which we have already developed at Nazarbayev University, so is able to give the information about the current, about the voltage, about the active power, reactive power, and it's able actually to give you even the power factor. In the meantime, it's able to calculate the total electricity bill from the beginning of each and every month for you. So looking to this feature, so let me tell you that this meter is able, if you are looking actually to this top menu, this meter is able to give you information actually about the weather condition in real time. And it is possible that you change the setting of this meter for different kind of, basically electricity prices or so you are changing the tariff, you are giving the dynamic tariff, you are changing the scale of actually, the price from the euros to the US dollar to the British pound and these sort of things. So to complete the setup, of course, we need to calibrate our device with a kind of very, very well-recognized device, which is actually our power quality analyzer. So looking actually to this setup, let me give you some explanation about the setup. So we have got a kind of resistive load, which is playing for us, so as a kind of lighting load, if it's supposed that still we are using the conventional lamp, because you know that the new lamp, they have got the inductive and capacitive actually, correct? So, and then we put in the circuit, so a kind of inductive motor, which can play for us as a kind of inductive resistive load. So these two actually, load which we completed in a simple setup, including the power source, is already connected using DCT. So to our developed actually a smart meter, and to our actually power analyzer. And these two guys, they are getting synchronously the same data from the wire which is going to the load. So basically, more or less, we're going to play with the load, we're going to change the load, and we're going to look at the data which we are obtaining from the power quality analyzer, and we are obtaining over our smart meter to see that how much we are calibrating. This is something which I'm going to ask actually our team members at first to show it to you, and after that we will look into the application which we develop for the mobile, and you can grab the entire information and in the entire data in real time from your appliances, from your home, your apartment, so your building, your commercial office, your industry, so basically over your portable devices. So I wanted to ask Nur Sultan, so as one of the team members actually in this project, so to explain more for you and more of course in detail for you about the smart meter, and he's talking a little bit about the clouding system, and of course he's changing the voltage, he's running the setup and this sort of thing. Hey, Nur Sultan.
Hello, my name is Nur Sultan. Now let me show you more details about our smart meter. First of all, our smart meter has two sensors, which is CT and power adapter, that measures current and voltage. Then this data goes to microcontroller inside our device, and it calculates power, active power, apparent power, and power factor as well. Now let's proceed to demonstration, and let me increase the voltage, which goes to this setup. Let me increase it up to 70 volts. First, let's see what values are shown on our IoT high precision equipment, and it shows 71 volts and 2.2 amperes. And if we see on the smart meter, we can see that voltage is also 71 and current is 2.22, which are exactly the same values on our smart meter. Concerning the power and power factor, we can see that 152 watts and power factor is almost 1, and the same goes here, 150 watts and almost 1 power factor, which is very accurate results. Now let me play with the power factor of this induction motor. As we can see, the power factor has dropped down to 0.92, and on our smart meter we can see that the power factor is 0.92 as well.
So you can simply find here actually the data which is grabbing with the power quality analyzer is similar to the data which we are getting over our smartphone. Smart meter. So it is showing actually that the smart meter is right now completely calibrated. So and the results are pretty close together. So the other things which the team members has been developed for this specific smart meter is actually the application. I'm going to ask Azamat and the other team members actually to explain for you about this application. Azamat, yes please.
Hello, my name is Azamat. Let's proceed to our smart meter and our application. Here you can see that, as Nursultan mentioned before, that everything is measured via CT and the VT, which is voltage adapter. So this data goes to the cloud, which is in our case is Amazon, and goes directly to our mobile application. Here you can see price. It's regarding the electricity bill consumption, current, voltage. The mobile application was designed for the comfortable usage of the consumer to be more precise, to be more aware of their power consumption and the price of electricity.
Okay, so thank you team members actually to explain about this smart meter. Right now I'm going to ask the team members to a little bit play more with the load to see how this meter is going to be changed, the data. So, or record the data actually. So Nursultan, can you please actually
Sure.
change that one?
Let me increase the voltage and change the power factor. So right now it shows 112 volts and the current is 3.70 amperes. And over our smart meter we can see that the voltage is also 113 and the current is 3.14 amperes, which are the same values. For power factor is 0.98 and over our smart meter is also 0.98. And as we speak, it collects the cumulative power and multiplies it with the price nowadays. And we can change these settings over our settings button so that it will be changed depending on daytime, is it morning, evening or night, and is it industrial, commercial or residential area. And let me change it once again to some smaller values. So if we have 38 volts right now and 1.19 amperes, we can see that over our smart meter the voltage is 38 and 1.17.
So in case if you are getting actually the data or the total consumption of the current exceeded more than the gauge, the total actually calibrated gauge, if the camera is getting close, I can explain that one. So you can double click on each and every gauge. And by double clicking over each and every gauge, you can change the gauge. For example, right now the maximum gauge here is going to be 10 ampere. However, if I'm double clicking on this one, so the gauge is becoming up to 1000 ampere. So if you double clicking, you can change actually different kind of the gauge, and the gauge would be adaptable. However, the data which you are getting here, so it is almost the same, always the same, because it's not supposed actually to be changed. So by the way, this is the smart meter which up to now, so our team members has been developed. So the next option for this smart meter would be the system which is going to forecast the load, so load forecasting actually option for this one. So anti-theft system is another thing which we are planning actually to develop it. And of course, so our team member Azamat is supposed to work on the THD calculation and harmonic and spectrum calculation for the current which we are grabbing using this actually meter. So let me tell you that. So if we can practically implement such a kind of a smart meter in our region or probably in the world. So we can say that, so we have it completely actually, the access to the data, which we can perform different kind of calculation and different kind of the action over the data, including actually the load profiling, including the load forecasting. And if we access to the data, of course, for the load profiling, using the load profiling, we can detect and we can recognize what kind of load is right now connected in your apartment actually to the smart meter. So actually, we can say that, or you can look into the application, you can recognize that what kind of load is right now working actually in your apartment. I really hope that you have found actually this demonstration and this video useful. Thank you very much for listening to us.